Hello everybody. Today's lesson is all going to be tied to the bell curve and the empirical rule. But before we start that, let's talk about where we've been so far in this class. So in stats class, I know this has felt like forever in this unit, but this third unit that we're going in is all tied to data description. And data description all is about like what kind of calculations can I do to a data set to help me describe my data set even better rather than just showing you my raw data and all the numbers like in a scatter plot kind of thing. So there's two different ways you can measure your data set. So there's measures of central tendency, and we've talked about all of these. So the mean is a measure of central tendency, the median, and the mode, where the mean is the average, the median is the middle, and the mode is the number that's occurring the most often. All three of these things are considered to be an average in air quotes because we're asking like what is typically happening within the center of my data set. And every single one of these three things can be considered as an average or something happening within the center of a data set. So that's why it's really clear to mention when you say average, if you're meaning like the actual mathematical arithmetic average where you add up all the numbers and divide by how many numbers you have, you should be using the word mean, because on average can be a little more ambiguous talking about mean, median, or mode. But in any case, those three things are talking about how you can measure the central part of your data set or the average of your data set. Now we've moved into things called the measures of variation or spread. So if you want to figure out how far spread apart your data set is, like how far the range is, so like your range may not be very big, which means that your data set is not very spread. So if you have a range of one number, that means that you have just two repeating numbers all the time. So if you have numbers like 12, 13, 13, 13, 13, 12, 12, 13, back and forth like that, your range is only one, which means that the spread of your data is really, really close knit. And in the world of statistics, basically what they're saying is that if you have a really small spread, that means that your data set is actually really reliable. Typically, not all the time, but typically. So we've talked about range, or the highest number minus the lowest number, but now that we're getting into the whole entire class of statistics, the range is not a good enough description of spread of data. So we've come up with these two other calculations that we learned, the variance and the standard deviation, where the variance is just some big number that, like, the bigger the number is, that's just designating that your spread is really big or really small. And then the standard deviation is the square root of that variance number, and it's more specific because when we talk about standard deviation, when we think about standard, it means typical, like the norm, that kind of stuff, right? And deviation means how far does it deviate. So if we're talking about, I told you today's lesson is about a bell curve and the empirical rule, so let's draw a bell curve really quickly. So if we have a bell curve, right, and this is going to be a horrible drawing, so I'm sorry about that, but in the middle, assuming this is the middle, this is your average, which I'll call x bar, because we always call the average x bar. When you say standard deviation, you're saying a data point that lies over here on the number scale of your range or whatever deviates from that average however many points, whether it's one standard deviation or two standard deviations, but it's deviating from that mean. So they're saying for any particular data number in your set, how far is it deviating from that norm or from that average? So that's what we mean when we have a number that we've calculated called the standard deviation. And so far in this class, all we've done is used our calculator to find that number, and we know kind of vaguely what it means in the case of this bell curve, but finally today is going to be the applications of standard deviation. Okay, so this is where the empirical rule comes in. So the empirical rule, or what is called the 68, 95, 99.7 rule, which is a lot of numbers, I know, but it's the breakdown of the normal bell curve. So when we talk about standard deviation, we use the letter K, just how like we use variables all the time in math to represent things. When you find the area of a triangle, we do 1/2 base times height, and we represent the base as B and the H as, or the height as H. For whatever reason, we use standard deviation with K. So when we talk about the number of standard deviations away from a mean, because the bell curve is symmetric, if we're saying one standard deviation away from the mean, it also has to be one to the left of it and one to the right of it. And when we say two, it's going to be two to the left and two to the right, and so on. So the percentages of this empirical rule are saying for any typical normal distribution or for any bell curve, 68% of your data should fall within one standard deviation of the mean. If it doesn't, that means that you probably don't have a normal distribution or a bell curve. And then 95% of the standard, or 95% of the data will fall within 2 standard deviations of the mean. And then 99.7% of your data should be falling within 3 standard deviations of your mean. So then that means if this whole graph represents 100% of our data set, right? So if we split 68 in half, you get 34 and 34. If you split 95 in half, so 95 in half, 95 divided by 2 is 47.5. So 47.5, but minus the 34 and minus the 34 to get just this region. Because remember, the 95% is talking about this whole region. So if you wanted to just know what this portion is, you have to minus the 34 off, minus the 34 off to figure out what this is. So basically you're taking 95 minus 68 divided by 2 and getting 13.5. And then if you're taking 100% minus 99.7, that's what's left here. And then of course divide it by 2 and you're left with this, right? So we're going to use this breakdown. So when they say number of standard deviations, so when we say 1, the 68% is plus or minus or on either side of that average. When we say 2 standard deviations away, it's plus or minus, okay? So this bell curve is going to represent, for our problems that we're going to be solving, we have 3 examples coming up, like where your data is falling and how much data is falling where. So like when we say 34% of our data fell from here to here, now we're actually going to know what those numbers are. We're going to know what the average is, and we're going to know what 1 standard deviation away is. So 34% of your data is falling within 1 standard deviation away, or it's deviating 1 away from the mean, and we're going to have that number that we've calculated and found. So you may want to write this bell curve down with all of these percentages because you're going to need it for the example problems. And you can also write this down if you don't want to write all these words up here. But you definitely need the percentages, whether you want to break it down or if you want to write it as the table. But you're going to need probably both. So however you want to write it down. Okay, with that, let's look at 3 examples. And sometimes it's easier to just look at examples with why things are the way that they are instead of just explaining it without an example. So hopefully once we do these examples, it'll make more sense. That's all I'm trying to say. Okay, so given an approximately normal distribution, okay, so a bell curve, that's what they're saying, with a mean of 175. We don't even know what these numbers are representing right now. The homework that you'll have will have like real things like pounds of wheat or ounces of Coke or Coca-Cola, that is, the pop, anyway. Stuff like that. It's going to have like actual descriptions. Right now I just have weird numbers that don't represent any real data set. Just to give you an example. So given a normal distribution or a bell curve with an average or a mean of 175 and a standard deviation of 37, what percent of your values would fall between 138 and 212? So let's draw this bell curve, right? You can draw it. I just copied and pasted the picture. So the average is 175. Okay, and they want to know what percent of values are within the intervals. Well, first of all, we need to know where these intervals fall. So if we have a standard deviation of 37, let's add 1 standard deviation, so 175 plus 37. That means that 212 would be right here. Well, that was one of my numbers, so I'm going to stop there. And then if we take 175 minus 37, we get 138. So from here to here was the interval that they're describing, and we found it just by simply adding and subtracting that standard deviation from that mean. So the question was, what percent of values are within that interval? And so our percent would be 34 plus 34, or because we know we're 1 standard deviation away, our answer then is 68% of our data values fall between that interval. So 68% of our data, let's say this was pounds of cereal or something, fell within 138 pounds of cereal to 212 pounds of cereal, given that normal distribution. Okay, number 2. Given an approximately normal distribution with a mean of 121 and a standard deviation of 40, what interval contains 99.7? So as soon as you see what interval, we're going to have to be adding and subtracting to find those tails of the bell curve. And when we know 99.7, think back to that table a couple slides ago, and this means that my standard deviation on both sides is, or k, is going to be 3. Right? So when we're within 3 standard deviations of the mean, that's 99.7. When we're within 2, it's 95, and when we are within 1, it's 68. And remember, k has to represent both the right and left side of the bell curve because s represents one singleton standard deviation, whereas k represents both sides of the bell curve. Okay, so our mean, so you're going to draw this bell curve again, and you'll get used to drawing the bell curve and drawing this out because this is the easiest way to think about this. So our average is 121 and our standard deviation is 40. So we're going to fill in every single one of these little slots. So 121 plus 1 standard deviation, or plus 40, would be 161. And then you're going to add another standard deviation, or 2 standard deviations from the average. So it's going to be 161 plus 40 is 201. And then, of course, plus 40 is 241. So now you're taking 121 minus 40, and that's going to get you 81 on this side. Minus 40 is going to be 41. Minus 40, of course, then would be 1. So their question was, what interval contains almost all of my data set? So your values, because we don't have any units like pounds or inches or something, is going to be from 1 to 241. That is what our interval is. And sometimes they say like inches to inches, pounds to pounds, centimeters to centimeters, all that stuff. I just had random numbers, so we don't have an actual context in this problem. Okay, so I'm kind of speeding a little fast, so I'll take it a little slower now. So the whole point, you might be getting lost in all this math, like, little Phil, why does this matter? So people are always curious, like we've talked time and time again, statistics answers the question, what is normal? And then, is that normal? So the bell curve determines that the average, like the mean of a data set, is what's normal. And then when you say, is that normal? Your question is it really close to that average, or is it falling super far away from that average? So the bell curve and the empirical rule are there to find all these questions about how many data points fall within this range. How much percentage of that is my whole entire data set? Those are the kinds of questions that are happening, and those are the kind of questions that we're asking in this example, and this is what we're doing. So we have one final example, and it's going to take a little more thinking. Okay, so a bottle filling machine fills, on average, finally a context. Thank you, Littlefield, for making an actual context to a problem. Okay, a bottle filling machine fills on average 20,000 bottles a day with a standard deviation of 2,000. If we assume that the production is normally distributed, okay, draw a bell curve, done. And that a year comprises 260 workdays, calculate the approximate percentage where under 18 bottles are filled. Okay, so what we're finding is a percentage. So that all of these problems, you guys, you're going to start with using the mean and standard deviation to fill out the bottom part of the bell curve, and then you're either answering a question with a percentage or you're answering a question with a range, like from this to this. Okay, so the first step is our average is 20,000 bottles. So that's where this goes, 20,000, 1, 2, 3. And then our standard deviation is 2,000. So sometimes, like any other math problem, and you guys are so sick of it, they give you extra information. So that was not needed. Okay, so now we're going to fill out the rest of our chart. So 20,000 and 2,000, so that means we're going to add 2,000, so that'd be 22,000. Add another 2,000, that's 24,000. Add another 2,000, that's 26,000. And then subtract, because now we're going away on the left side, so it's going to be subtract. So 20,000 minus 2,000 is 18,000. Minus 2,000 is 16,000. Minus 2,000 is 14,000. Okay, so if you have questions on how to fill this out, all I'm doing is starting with the average, and then I'm adding the standard deviation once, adding it again, or adding it twice back from that average, and then adding it 3 times. And then I'm subtracting when I go left. So I'm subtracting the standard deviation once, subtracting it twice, subtracting it 3 times. Okay, So the question was calculate the approximate percent where under 18,000 bottles are filled. So if this is where 18,000 bottles are filled, is like this part of the bell curve, they're asking what percentage fall beneath that. So if this little section represents 0.15, then we have to add this section and this section and this section together to see how much is below that 18,000 mark. So it's going to be 0.15 plus 2.35 plus 13.5. So if you add all of those things together, you should get 16%, which is your answer. So 16% of our bottles are under 18,000 bottles that are filled. So 16% of the bottles that we fill are below 18,000 a day. Okay, so hopefully these 3 questions help you with the quizzes that you're going to be doing after this, or the homework problems. So with that, I will leave you to taking these notes, and if you have any questions about the notes, or if you're confused about why this is important or why this is relevant, then please let me know. Next week we're going to be taking these thoughts and ideas to all the COVID-19 stats to get it into a real world perspective about the normal curve and what it means to flatten the curve and all that other stuff, right? So yes, make sure you get these notes down, and then if you have any questions, please always feel free to reach out and let me know if you need help. Okay, bye.